How you doing, Mark?
Morning, Tom.
Good to see you.
too.
Thanks for being our EndoFlex patient. We're going to go through the whole process and teach how this prosthesis is made from start to finish. And we're going to utilize you as the guinea pig. Thank you very much. Take your coat off. Okay, here we are. This is the beginning of the class. Mark is a patient who just came to us last week with a 5-year-old prosthesis. It was his first definitive given to him in Phoenix after a traumatic amputation. He's in an exoskeletal crustacean design with a satch foot. Let's take it off and take a look at it. He's also, since he's traumatic and he has no other medical problems, he's very hard on his equipment, whether it be prosthetic or otherwise. And the amazing thing is, there's a few issues here I want to go over with you. If you look at this prosthesis, does anybody see any suspension involved in this prosthesis? There's no suspension at all. Look at this. Pretty well-fitting limb after 5 years. Okay? Now, why is it so difficult to get off? You'll see the answer. This has nothing to do with EndoFlex, but what's interesting in seeing him, he's got very good gastroc definition in here. He had a little bit of an adhesion which is cleaned up. His distal tibia is pretty well beveled, but as you can see, he's got very little distal padding. His length is about half the length of the tibia, a little bit long on the long end. So what we're going to do is, since we're making an EndoFlex prosthesis for him, we want to maximize the amount of cylindrical pylon in this case because he doesn't have that much room to begin with. So we're going to go with a Seattle Lightfoot so that this way we can mount the pylon down deeper inside the prosthesis. Also, since the guy's traumatic and he's young and he's very healthy, we're going to go to suction with him, even though he may not even need it because he's well suspended with just the gastroc definition. But suction being such a popular method of suspension, we're going to try it for him and see how he likes it. If worse comes to worse, we'll eliminate it. Okay, so we're going to first go through the casting procedure. Now, of course, this is what he's got. Did I go over the fact that he had a satch foot on this and exoskeletal? There's actually absolutely no dynamics to this prosthesis at all, except for the toe break from the satch foot, which is ready to come off anyway. It served him well, though. 5 years out of this thing, and his gait is very nice. It just goes to show you, with all the technology we have these days, you put a guy on a real healthy traumatic amputee on basically a prosthetic design from 25 years ago, and he can walk just as well as a guy with a flex foot. It's going to be interesting to see where you end up with this after we change the technology, and to get your opinion on what the difference is. My guess is that you're going to go through a stage where you go, oh, wow, ooh, this is unreal, this is so different, and after about a week, you're not going to even notice the difference between this and the other one, right, unless you switch back into it. That's the way it is with amputees. And the interesting thing is that with all the technology, an experienced amputee can try on anything, go through a level of change and adjustment to that new system, and then before you know it, it functions just like anything else does somehow. So the way we do this is we're going to cast him over a silicone liner because, of course, we're going to make this thing over. We're going to make this prosthesis with silicone. So the way I like to do it is cast him over the liner so I have the image of the liner and his body to work with. So we're going to powder this up. In the future, try not to use scented, but since he's traumatic and it's not going to make a difference, it won't make a difference to us. Okay. Now the whole thing with this EndoFlex casting procedure is that what we're really doing here is using old style technology and marrying it to new materials and components. For example, years ago, when a craftsman made a prosthesis out of a piece of wood, they take a piece of wood and carve it into a socket and then shape it down into a foot. They knew where the foot belonged right from the beginning because they didn't want to be cutting it in half and gluing it back together. They studied alignment from the start, so that this way the foot was very close to where they wanted it at the end without having to do many adjustments. All right, scoot towards me, Mark. And then what happened was, with the advent of modular componentry, By the way, we're going to cut this down at the end anyway. More of that. With modular componentry, what happened was you build the prosthetic socket, you bolt it onto an adjustable tool, and then when the thing was completely built but not aligned, then you put on the patient, you tweaked it here and tweaked it there until you got it to work right. The whole philosophy behind EndoFlex is to avoid that whole stage and try and get your anatomical alignment as close as possible right from the beginning. And what we call it is NEAT. It's normal endoskeletal alignment technique. And what we're really looking to do is copy the alignment of your body. So if I get a clean sagittal line from the center of your hip through the center of your knee, that's going to get me very close to where the center of your foot belongs. You know what, Eric, could you do me a favor and bring that skeleton up here so we can get a good look at it? I also need a yardstick. Yeah, thanks. So that's what we're going to do. Instead of saying your socket's got to be 5 degrees adduction and 5 degrees flexion, and then we'll put it on and figure out where it belongs, we want to know where it is now. So the idea is that I want to capture your alignment while I have you in my hands. So that's why the pin for the shuttle lock has to be in line with a clean sagittal line in the sagittal plane and the frontal plane. All right, now the next step is we'll take a piece of, Frank, if you want to get a view of this too, you can see, if you want to look from over here, you can see where this pin is now in reference to the center of the hip and center of the knee. And that pin is not off center, it's really in alignment with the hip and the knee joint. There you go. Yardstick. See, there might be one right here. Okay. I'm going to use Mr. Bones over here as an example. One of our old employees, his brain is short-circuited after we had his jaw going up and down, and that's the way he ended up. So, but anyway, the point that we're trying to make is, in theory, the weight line is coming exactly from the center of the hip, which is here, the center of the acetabulum. It's not off the trochanter. Even though the femur comes on an angle, the weight line is coming from the center of the hip through the center of the knee. And that's what will give you where the center of the foot belongs. In fact, when I first started in this whole thing with EndoFlex, every single one of my patients was thrusting laterally on weight bearing. They're all getting this lateral thrust. Why? Because I'm looking at the trochanter in this region as being the center of the hip joint, but it's not. The center of the hip joint is where the body is loaded. That's the interesting thing about the human body. If you look at this structure, this is really basically a very unstable structure. The weight is not going directly through the bone. However, if you look at the mass of the femur, that explains the reason why we can carry all our weight that way. So again, the idea is now to get a straight line between the center of the hip, through the center of the knee, and that'll give you the center of the foot. Of course, if there's any external rotation, that's another situation you have to address. Most patients don't really exhibit external rotation, but if they do, you just accommodate that. If the foot is externally rotated, you're still going to reach the same answer. Now, also, from a flexion angle, if the patient has no knee flexion contracture or has no knee flexion that has to be accommodated, then you do the standard 5 degrees of flexion, which you can see between the line of the femur and the line of the tibia. Okay? Now, if the patient does have a knee flexion contracture, okay, so imagine the knee is flexed like this. Now, your weight line is still going to come straight through here because you're accommodating the fracture, but you still have to maintain the weight line through the long axis of the femur. All right, now Mark has no knee flexion contracture. He's got full range and he's got full strength. So we're going to cast him straight forward on this.